It turns out when you're creating your own classes, you're going to be using the private access modifier for your attributes. This is almost always the case. Of course, there are exceptions, but the reason we make our attributes private is because we want to enforce encapsulation. So, what is encapsulation? It's an object oriented programming principle that bundles data and methods that operate the data within a single unit, a class, while restricting direct access to some of the object's components. So, this last sentence is the important part. So, I know this definition is a little bit academic. I want you to take away this definition instead. So, it means keeping the data, which is the attributes, right? So, the object's data is described through attributes. Another word for that is state. So we want to keep those attributes safe inside the object by only allowing other code to change or see it in a controlled way. We're going to do that via a special type of methods really, called getters and setters. We'll explain that in the next couple slides. So what does this mean for you? Well, it means that you're going to make your attributes private, and then you're going to create special methods called getters and setters, and those will indirectly go in and set the value or get the value, access the value or change the value. So yeah, use getters and setters instead of direct access. Direct access is bad because that's not going to be encapsulation. So why do we do this? Well, of course, we'll explain this in the next couple of slides. All right, so before we actually get into why, I need to show you the how. So how do we actually prevent that direct access? How do we protect our attributes? That's going to be through getters and setters. So these are special methods. We've already learned how to write a method. And the name is kind of self-explanatory, right? There's a method to get the value, get the attributes value, and one to set the attributes value. This is going to allow us to prevent that direct access. So it's going to enforce encapsulation, which will protect our data while still allowing us to get access, right, to that information. So you don't have to use these methods. You don't have to use getters and setters to access and update attributes, but it is a convention, right? It's a best practice because we want to achieve encapsulation. So here's what it looks like without getters and setters. So it looks a lot like accessing, or calling a method rather than, I shouldn't say accessing, right? I should say calling for methods. So it looks like you're calling a method, dot, right? It's the object name first, and then instead of the method name, it's the variable name. We're only able to do this if we make the variable access or the attribute access public. This wouldn't work if we made it private. But yeah, say we made it public. This is what it would look like. So this is direct access. Now, it's not clear here why this is a bad idea. In some of the next slides, it'll be a little bit more clear. So here's access with encapsulation with getters and setters. So we're going to make the mileage private this time. And then we're going to have a getter that will return the mileage value. So that's all it does. It's an int, so we have to do int return type. And then we're returning the mileage value. And then we have the set mileage, which has an interesting twist. And this is a great example of why encapsulation is so important. Mileage values should not be negative. They should never be negative. So this set mileage has a little extra check. It says, hey, if you try to input a mileage value that is not greater than 0, I'm not going to set the mileage. I'm only going to set the mileage for positive values. If M, the input value, is positive, I will set the mileage value. If not, I'm not going to accept that as a valid value. This is going to protect your cars because your car shouldn't have negative mileage. There's no such thing as a car, with a negative 100 miles. Mileage is always a positive value. If your car went in reverse, that doesn't make the mileage go negative. So here's an example of setting the mileage with the method. So it looks clean, a lot more readable. One of the reasons we also encapsulate and use getters and setters. This is more easy for a programmer, right? Perusing through your code, they can see immediately, oh, they set one of the attributes here. And then we have a getter. So if we're going to assign the mileage value to a variable like miles, we can do mycar.getMileage. And your getter is always going to have, the same type as your attribute. And your setter, because it's not really returning anything, it's usually going to have a void return. because all it's doing is some kind of action. We don't actually have to return the mileage value. All right, so let's see an example, right, of how things could go wrong. Well, say you wanted to set a negative 5,000 mileage value, right? Somewhere in the code, it tried to do this. Um, it doesn't make sense, right, for a regular person to do this, right? But when you're writing really complex programs, some parts of your code might do this by accident. It's totally possible. So this is invalid, but nobody stopped it. There was no setter that could fine tune the axis and setting and getting right of that attribute. And so this car would be totally messed up because it's going to have a negative mileage value. I can't sell this car on the website because people are going to see the mileage and be like, what the heck does that mean? So yeah, what are the benefits of encapsulation? Why should we follow this convention? It's going to protect your data from unwanted changes. It's going to stop other parts of the program from changing the data by mistake. It also allows validation, like we saw here, right, with the if statement. We're only going to take valid values. We're going to validate those inputs. So if attributes are public, anyone can change them freely, even in dangerous or incorrect ways. And then here it makes your code more modular, secure, and maintainable. Helps keep the program organized. And like I said, I like the syntax, right? I can see very clearly I'm performing an action on the car object. I'm setting its mileage. I'm performing another action. I'm getting its mileage. So getters and setters definitely have that readability over just straight access. There is an example, by the way, where you do access an attribute directly. That's with arrays, because arrays behind the scenes, right, is a class. When you do dot length, uh, I believe that is not a method, sorry, an attribute. So remember when we write our loops, we do the array name dot length as the end of the loop. We're actually doing direct access. So there are cases, right, where you can do direct access, but for the most part, when you're writing your own classes, you want to go private. You want to achieve encapsulation. That's a good programming paradigm. So if you want to be a good programmer, you got to use getters and setters. Even though it looks the setup is a little complex, um, if you're watching the videos, if you're not, you're gonna miss out on this. I'll actually show you a way that IntelliJ can write the getters and setters for you, so you don't even have to write them. All right, so that's access and encapsulation. So with encapsulation, right, if you want to set the speed, for example, it's better, by using the getters and setters.